In the next 5 minutes, you are going to make a program that measures the distance of an object and displays it in the serial monitor. Hi, my name is Jeremy, and welcome to the 14th tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid-State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous videos as this one will build on their material. Today we will be looking at the ultrasonic distance sensor. As the name implies, it uses ultrasonic sound waves to measure the distance of objects. This uses the same technology as sonar. If we take a look at the device, you will notice two metal cylinders. The left one is a speaker and the right one is a microphone. When triggered, the speaker sends a burst of sound waves that travel through the air, hit any objects in the way, and reflect back to the sensor, where they will be picked up by the microphone. The speed of sound is approximately constant through air. Therefore, the distance of an object can be calculated by measuring the time it takes between transmitting the sound signal, having it reflect off the object, and receiving it at the microphone. The longer the delay, the farther the object. We can use the following equation to convert from time in microseconds to distance in centimeters, where c is the speed of sound in air, 0.0343 centimeters per microsecond. Here we divide by 2 since the sound wave must travel twice the distance, once to reach the object and again to return to the sensor. This device can measure distance anywhere from 3 centimeters to 4 meters and can see within a 30-degree angle. The sensor has 4 pins. From left to right, we have the 5-volt supply, the trigger input, the echo output, and ground. Let us build a circuit that senses the distance of an object and sends the result to your computer using the serial bus. Remember to disconnect your Arduino to avoid damaging any components. Take your distance sensor and place it on the breadboard as shown. Then connect the power pin to 5 volts and the ground pin to 0 volts. Finally, connect the trigger and echo pins to any 2 of the Arduino's digital ports. I will use port 9 for the trigger and port 8 for the echo, but you may use any of these ports. Next, let's write the code. Begin by specifying the trigger and echo pins. In my case, int trig port equals 9 and int echo port equals 8. In the setup function, initialize either port with pin mode trig port output and pin mode echo port input. Also, initialize the serial communication with serial.begin 9600. Next, in the loop function, tell the sensor to perform a distance measurement. Set the trigger to high with digital write trig port high. Wait 10 microseconds with delay microseconds 10, and return the trigger to low with digital write trig port low. Then measure the delay with float duration equals pulse in echo port high. Using the equation we just showed, convert from time to distance with float distance equals duration over 2 times 0.0343. Print the result to the serial monitor with serial.println distance. Finally, delay the program with delay 200. And you're done. Plug in your Arduino, upload the program, and open the serial monitor. If successful, by placing an object in front of the sensor, its distance should be displayed in centimeters. And by moving the object closer or further, the distance should update automatically. If so, then congratulations! Feel free to play around with the distance sensor. I challenge you to make an obstacle-avoiding self-driving car. Use a DC motor to power a miniature car and a distance sensor to detect obstacles. The car should stop before hitting any walls. Join us next video when we will learn to use infrared sensors.